Welcome to section 1.3, Linear Equation Review, part 1. So we're going to be looking at some of the things that you should have learned and remembered from Algebra 1, how to come up with equations of lines. This will be very critical moving forward with the next section. Let's take a look at a couple problems. But before we look at problems, let's remind you of two very important formulas that are going to help you throughout this section. First of all, the formula for finding slope. Remember what that is? That's like change in y over the change in x. You may have seen it written with these triangles, delta y over delta x. That's just nothing more than this fancy formula. It doesn't really matter which x value goes first or which y value goes first, as long as the corresponding x or y value goes first with the other as well. And then we have slope-intercept form, or y equals mx plus b. You're very used to seeing that. The only other formula that you may come across in some of your math is point-slope form. I'll write that down here, point-slope form. This is one of those that we can get away without actually having to have memorized, but it may be helpful in some instances. So example 1, write an equation of the line in the slope-intercept form. Okay, so you're given a graph here, and we want to write the equation of this line. Now, first thing you want to look at is we want to look at the equation of a line, y equals mx plus b. And remember what these different parts mean. So remember that m represents the slope, and represents that b represents the y-intercept. So if I can identify the y-intercept, and if I can identify the slope of the line that I'm given, then this problem should be pretty easy because I can just fill in some numbers. So, lucky for me, when I'm given a graph, the y-intercept is very obvious. It's wherever the graph crosses the y-axis. And in this case, it crosses at the point 0, negative 1, which means the value for b is equal to negative 1. The slope. All I got to do is find two nice points. And nice points, what do I mean by a nice point? I mean, where does the graph cross at a nice coordinate pair? So I do see this the y-intercept here. If I go up here, here's this point right here. What's that point? That's points 3, 1. And if I look at that, that creates for me a really nice spot where I can look at the slope. And if you remember the other way that we think about slope, other than the change in y over the change in x, we can always think of it as a rise over run. And in this problem, I'm rising 2 and I'm running 3. Therefore, my slope, or m, is 2 over 3. So what's the equation? Y equals, we fill in the slope, 2/3, x, and then plus negative 1, but we'll just write minus 1. So the equation of the line is y equals 2/3 x minus 1. But what if we're not given a graph? What if we're just given two coordinate pairs? It doesn't change what we do. Just the work is a little bit different. We're still going to work to identify what the slope is. And if we remember that, that's actually even easier in this problem because we just follow a formula. So let's see, it's a change in y. So I'm going to use this as my x2 and my y2 because it's the second point. And then this will be my x1 and my y1, because it's the first point. So let's see here. It's y2 minus y1. So negative 5 minus 1 over negative 3 minus negative 5. And I just do the math. So let's see here. Negative 5 minus 1 is negative 6. Negative 3 minus negative 5. Man, I like to think about that as plus the opposite, right? Change both those signs. So I think of it as negative 3 plus 5, which gives me 2. And get down that to negative 3 being the slope. So I've identified the slope. So far, I have y equals negative 3 x plus b. Now I just have to figure out what the b value is. This is where you're going to take one of those points and we're going to plug them into the equation. So I'll take the first one and I'll plug the negative 5 in for my x value and the 1 in for my y value. So I'll come up with y equals negative 3 times negative 5 plus b. And I'm going to take this equation and solve for b. So let's see, that's 1 equals negative 3 times negative 5 is 15 plus b. I'll subtract 15 from both sides, and I'll come up with b equals negative 14. Now it's a matter of just sticking it all together. So y equals m, which is negative 3, x minus 14. That would be my final equation for this problem. So at this point, what I'd like you to do is I'd like you to pause the video, and I'd like you to try out these two problems. See what you come up with. Pause the video, try them out. Okay, so now that you've tried them, for the first equation, we can look here and we can see the y-intercept is 0. It actually goes through the point 0, 0, so I know b is equal to 0 here. And the slope, what's the slope? The rise over the run. Looks like I'm rising 2 and I'm running 1. So my slope is equal to 2 over 1, or just 2. So when I write out the equation, this is just y equals 2x. For problem number 2, again, there's x1, y1, x2, y2, and we can plug in the equation. So I got 2 minus 3 over 1 minus 3, which gives me, let's see, that's negative 1 over negative 2, which simplifies down to 1/2. Now I'm going to go plug this into the equation, y equals mx plus b. And I'm going to plug in what I know. So the slope is 1/2 x plus b. Then I'll take one of my points and I'll plug them back into my equation. So 3 equals 1/2 times 3 plus b. And I'll go ahead and solve this out. So I get 3 over 2 plus b equals 3. And when I simplify that down, I'll get b equals 3 over 2, which means my equation, after I simplify it all out, is y equals 1/2 x plus 3 over 2. All right. Okay, example 3. Determine which lines, if any, are parallel or perpendicular. Let's remind ourselves what makes two lines parallel first. So from a geometry standpoint, parallel lines never intersect. But what makes them never intersect is an algebra concept. And we would say that the slopes are the same because the lines never intersect. So the rise over the run, or that ratio, has to be exactly the same for all lines that are parallel. Now, if the lines are perpendicular, that means that they meet at 90-degree angles. Okay, so the lines meet at 90-degree angles. So in mathematics, what that means is the slope of one line, the slope is equal to the opposite reciprocal of the other line. Okay, so like for example, if the slope of the first line is 1/2, then the slope of the perpendicular line is -2. Okay, so when we're looking to figure out whether two lines, or whether two lines that are created through these points are parallel or perpendicular, we need to find the slope. So this is essentially like taking 3 problems and finding the slope of each of them. So for line A, let's do the work down here. Line A, we're going to do 3 minus 0 over 0 minus -2. Let's see here, that gives me 3/2. Okay, and then let's look at line B. So I can't tell anything yet. So let's look at line B. Line B is going to be 1 minus 0 over 0 minus 3 over 2. Oh, gross. So that's -3 over 2. What would that... So mathematically, if I type that in, I need to remember that's like 1 divided by -3 over 2. So I multiply by the reciprocal. Okay, -2/3 is what I end up with. And finally, line C. What am I going to do with line C? Well, let's see here. That's 3/2 minus -3 over 3 minus 0. Okay, so this is the same as like adding 3 to that. And 3 plus 3/2, let's see here, that is 9/2 over 3. And again, if I think about what that is, that's like the same as saying 9/2 times 1/3. If I do that, that gives me 9/6. If I simplify that down, I get 3 over 2. Okay, so to review, the slope of this line is 3 over 2. Line C is 3 over 2. The slope of line B is -2/3. And the slope of line A is 3 over 2. So parallel lines have the same slope. So what does that mean? That means that line A and line C, so line A and C, are parallel. They're parallel because they have the same slope. And if you look here at line B, B is perpendicular to line A and line C. And it's perpendicular because the slope is the opposite reciprocal. We're going to keep that idea of what makes two lines parallel and perpendicular as we move into this problem. Find the equation of the line that is perpendicular to y equals 2/3 x plus 2 and passes through the point 0, 1. So we're always going to start back with the equation y equals mx plus b. And we need to identify each one of these parts. So the slope in this problem is not this line right here, but it's what's going to be perpendicular to this line. So because, again, we go back to this idea of opposite reciprocals. So my slope is going to be the opposite reciprocal of 2/3. So that means the slope is -3/2. All right, so I'll fill that into my equation. Y equals -3/2 x plus b. Now I'm going to go to the point that I was given and plug in for y and plug in for x and figure out what my b is equal to. So -1 equals -3/2 times 0 plus b. Well, -3/2 times 0 is 0. So I have 0 plus b, which is just b. So my value for b is equal to -1. Now I put it all together. So y equals m. It's this m right here, -3/2, x, and then plus b, which is -1. So my equation y equals -3/2 x minus 1. So why don't you right now pause the video again and try these two problems. I will make an observation about number 1. Do you see how I give you the equations instead of points? The idea is no different. Still figure out what the slope of each one of those lines is. That's my little hint to you. So go ahead and try number 1 and 2, and I'll give you the answers here in a minute. So go ahead, pause the video, try number 1 and number 2. Okay, so let's take a look at this first equation right here. This first equation, if I solve it for y, well, let's see, how am I going to do that? I'm going to divide everything by 4. So that gives me y equals, let's see, 2 divided by 4 is 2/4, which simplifies down to 1/2. So 1/2 x plus 4 divided by 4 is 1. Okay, so the first equation is y equals 1/2 x plus 1. Now if I look at it, the slope is 1/2. Okay. So that is line A. We'll call that one A. Now let's take a look at line B. This one we'll call B. If I solve this for y, let's see, how am I going to do that? Well, I'm going to add y to both sides, and I'm going to add this 1/2 x to both sides. What am I going to get? If I do that, this will cancel here, this will cancel here, and I'm left with y equals 1/2 x minus 7. And again, if I look at that, the slope of that would be 1/2. Okay, one more equation. We'll call this one C. So, oh, cool. I don't have to do anything for this one. This one is already solved for y. So I can look at that and tell that the slope is equal to -2. So what information can I tell from this? Well, since I know what the slopes are, I know that A and B are parallel, and I know that line C is perpendicular to A and B. Why? Because the slopes are the opposite reciprocals. 1/2 is the slope. The opposite, it would be negative. The reciprocal would be 2. So -2 is the opposite reciprocal of 1/2. All right, let's take a look at number 2. Find the equation for the line that's parallel to y equals 2x plus 1 and passes through the point. Okay, so parallel. Parallel lines means that the slope of my new equation is going to be the same as the slope of this line. So when I write y equals mx plus b, I know the slope is going to be 2 because that's the same as the slope of this other line. I'm sorry, I wrote a 2 here and I meant to write a b. My mistake. Okay, so y equals 2x plus b. Now we're going to fill in our points. So there's the x value, we'll plug that in for x. There's the y value, we'll plug that in for y. I'm going to get 1 equals 2 times 4 plus b, and I'll solve for b. So that's 8, that's 1. So I'll subtract my 8 from both sides, and I'll get b is equal to -7. All right, so my equation, y equals 2x minus 7. All right. Okay, now we have a word problem. while on vacation in Canada, you notice the temperatures are reported in degrees Celsius. You know there's a linear relationship between Fahrenheit and Celsius, but you forgot the formula. From science class, you remember the freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit, and the boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. Part A, write an equation that represents degrees Fahrenheit in terms of degrees Celsius. Write x, let x represent the temperature in degrees Celsius, and y represent the temperature in degrees Fahrenheit. Okay, so this tells me what x is and what y represents in the problem. So when I'm looking up here at my coordinate pairs, this also will allow me to line them up to know that I'm going to write x comma y, and x is Celsius, so this will be Celsius, comma, Fahrenheit. I can't spell Fahrenheit. There we go, right better. Okay, so when I write out these coordinate pairs that I'm going to use to try to find the equation, I'm going to write them in this form. 0, 32 for the 0 degrees Celsius and the 32 degrees Fahrenheit, and then 100, which is in Celsius, and 212, which is in Fahrenheit. And I'm going to go from there by calculating first the slope, and then figure out what the y-intercept is. Okay, so first the slope. So I'm going to use 212 minus 32 over 100 minus 0. Okay, let's see here. That'll give me 180 over 100, which if I simplify down is 8 over 10, which simplifies down to 9/5. Okay, so now when I go to my equation, y equals mx plus b, I know that m is going to be 9/5. So 9/5 x plus b. And I just plug in one of my numbers and figure out what the other one is. So I'll say 32 equals 9/5 times the 0 would be the x value that goes along with that, plus b. 0 times 9/5 is 0, which means my value for b is 32. Which means my final equation is y equals 9/5 x plus 32. Nice. Okay, the temperature outside is 22 degrees Celsius. What is the temperature in degrees Fahrenheit? Okay, remember, Celsius is an x value, and Fahrenheit, which is what we're trying, is the y value. So I'll go to my equation, y equals 9/5 times 22 plus 32. And I'll do that calculation. Let's see what I get. So I just plug 9/5 times 22 in my calculator, add 32 to that, and I get 71.6 degrees Fahrenheit. Always a good idea to put your unit in. So why don't you pause the video right now and try out this word problem. See if you can come up with the correct linear equation. Go ahead, pause the video, and then we'll go over the answer. Okay, so when I read this problem, and I see that in the first year, there were 35 participants, that gives me a coordinate pair, 1, 35. And then in the third year, there were 57 participants, so that gives me another point, 3, 57. All right, and I'm using then that x is the year number, right? Not the actual year, but the year number, the first year, the second year, the third year. And then the y value is going to be the number of participants. So that's going to be where I'm coming up with that second value. All right, write an equation that will predict the number of participants in any given year. Okay, so we'll go ahead and calculate the slope first, and we'll do 57 minus 35 over 3 minus 1. And 57 minus 35 is 22. And 3 minus 2 is 3 minus 1 is 2. So that comes up with a slope of 11. Now when I plug that back into my equation, y equals mx plus b. Well, so it'd be y equals 11x plus b. I'll fill in my numbers. So let's see here. That's we'll do 35 for the y value equals 11 times 1 plus b. So that's here. 35 equals 11 plus b, which means my b value is equal to 24. So my equation, y equals 11x plus 24. All right, part B, based on the equation, how many participants will there be in the fifth year? That's x. So we'll do y equals 11 times 5 plus 24, and I'll do the math. And okay, let's see here, 55 plus 24. So I know that there will be 79, or I can predict there will be 79 participants in the fifth year. 79 participants in the 5th year. Okay, cool. That's the answer. All right, folks, good luck. We will be going over some more of these problems in class, so come prepared to practice these problems. See you then.